So we want to find the relative maxima and minima of f of x equals square root of 1 minus x squared. It may be helpful to actually notice that f of x equals 1 minus x squared is actually y minus square root of 1 minus x squared, or the top half of x squared plus y squared equals 1. So this is the graph of this function is actually a semicircle with radius 1 centered at the origin. And so it's pretty easy to see that the relative maximum is going to be here and the minima are going to be here. So we should keep that in mind. Another thing to keep in mind is that this function only really has domain -1 to 1. So just be careful about that. Anyway, let's see what happens if we actually do this instead of geometrically doing this with derivatives and critical points. Taking the derivative using the chain rule, that's 1 over 2 square root, that's the derivative of the square root, 1 minus x squared, times minus 2x, the derivative of what's inside the square root. And we can simplify that a little bit to minus x over root 1 minus x squared. Here we want to find the critical points of f of x. That means we set f prime equal to 0, which means negative x over root 1 minus x squared is equal to 0. When a fraction is equal to 0, remember that means the numerator is equal to 0. We can, for now, ignore the denominator, so we see that x equals 0 is in fact a critical point. But the problem is, what about the denominator? Well, one thing to look at is that the denominator, you can think of it as, what if f of f prime of x, sorry, not double prime, f prime of x is undefined? That means the denominator is equal to 0. Or 1 is equal to x squared, x is equal to plus or minus 1. So, you can think about plus or minus 1 as sort of critical points of this function, but they're really the endpoints of the function. Since if you look at it up here, the minus 1 and 1 are at the edge of the domain, and also f prime is undefined when x is greater than 1 or when x is less than minus 1 as well. So this problem is a little tricky. If we did do a sign chart, or rather, let's just do the sign chart, right? We have 0, 1, and minus 1, x, f prime. And if we plug in a number between 0 and 1, say a half to f prime, you're going to get a negative number. The square root is always going to be positive on the bottom, but if you plug in a positive number on top, you get a negative number with that negative in front. So it's going to be negative here, and same logic applies to negative a half. If you plug in negative a half, the top becomes positive a half, and the bottom, well, who cares? It's a square root. It's going to be positive or 0. But we know that it's not 0 because x isn't 1 or minus 1. In any case, here we have then, this is a relative maximum as our picture illustrated, since f is increasing before 0 and decreasing after 0. And, well, f is kind of undefined after x equals 1, and before x equals minus 1. So we can't really do the first derivative test there. It won't make any sense. In fact, if you try to do it, you would start getting complex numbers. So, that doesn't make any sense at all. So we won't do that. What we can say, though, is that because f of 1 or x equals 1 is the last point on the function, and f goes down to it, this is really a relative minimum. And also, since f leaves minus 1 by going up, can say f of minus 1 is the relative minimum too, which our picture also illustrated. Pictures are good for that. So we can say that the relative maximum occurs at 0, and the y value is 1, so the relative max is 0, 1. And the relative min are minus 1, 0, and plus 1, 0. So when you have a function that only has a restricted domain, this whole idea of the first derivative tests and increasing, decreasing, it works in the middle, but towards the ends, you have to get a little creative. And it's important to actually know that the domain of the function is from minus 1 to 1. But even if you didn't know that, if you attempted to plug in numbers here and here, you would actually get complex numbers as a result, and that should be a sign telling you that the function doesn't actually exist there, since there's no derivative at all.